In an earlier video, we looked at equation of a circle given the endpoints of a diameter, where we mentioned that if the endpoints of a diameter are x1, y1, x2, y2, then the equation of this circle has this neat form where you multiply x minus x1 with x minus x2 plus y minus y1 times y minus y2 is equal to 0. And I also gave you a sketch of the proof, but in this video, let's prove it together. Let's get the center and radius first. So center is just the midpoint, which is x1 plus x2 divided by 2. Use the midpoint formula. And y1 plus y2 divided by 2. And radius is half the diameter. You can get the diameter by using the distance formula, which is square root of x2 minus x1 quantity square plus y2 minus y1 quantity square. This is the diameter, and you divide it by 2 to get the radius. Now we can use the center form of the circle, which looks like this: x minus h quantity square plus y minus k quantity square equals r square. If the center is hk and the radius is r, then that's what we do to get the center and radius. So all we have to now do is plug h equal to x1 plus x2, k equal to y1 plus y2, and r equal to this quantity, and then do all the necessary algebra to get this neat form. So let's do that on a separate sheet of paper. So it's going to be x minus that quantity square plus y minus this quantity square. So let's write it down. It's x minus h in our case is x1 plus x2 divided by 2 quantity square plus y minus k in this case is y1 plus y2 divided by 2, and then we are going to square that. So, and that is equal to r. R is this quantity, but I'm going to square it. So the square root will disappear in the numerator and the denominator would have 4 in it. So it's going to be a fraction where the numerator is x2 minus x1 quantity square plus y2 minus y1 quantity square, and the denominator is 4. Now let's expand this binomial square. So we'll use this formula. If you have to square a minus b, then it's going to be a square minus 2ab plus b square. There are these three terms. The first and last terms are nothing but squares of these, but there's a middle term which is twice the product of a and b. So when I square this, I'm going to get x square minus, I'm going to take 2 times the product of x and this quantity. The 2 and 2 in the denominator here cancel each other out, leaving me with just x times x1 plus x2. And then square of the last term is going to be x1 plus x2 quantity square divided by 4. Because there's a 2 which is squared, I get 4. Similarly, this part is going to look like y square minus y times y1 plus y2 plus y1 plus y2 quantity square divided by 4. All of this is just the left side of the equation, and the right side is right there, which we are going to copy. x2 minus x1 quantity square plus y2 minus y1 quantity square divided by 4. Now, in the next step, we are going to move everything to the left. So let's rewrite what we have on the left. It's x square minus x times x1 plus x2 plus x1 plus x2 quantity square divided by 4. Now if I'm moving this to the left, I can write this as minus x2 minus x1 quantity square over 4. I'm going to just consider this part, and I'm going to take this one when I'm writing the y's, plus y square minus y times y1 plus y2 plus y1 plus y2 quantity square over 4 minus y2 minus y1 quantity square over 4. And that is equal to 0. So if there was any confusion, I would like to clear. What I did is I copied these three terms first, and I split this as x2 minus x1 quantity square over 4 plus y2 minus y1 quantity square over 4, and then I subtracted this on both sides. So that's how I got minus of x2 minus x1 quantity square over 4. And then I wrote these three terms, and then I subtracted this quantity on both sides, and that's how I got it. So now notice that these two can be combined. So whenever I combine these two, what happens is, so let's go ahead and write down. Let me copy the first two terms here. It's x square minus x times x1 plus x2 plus, now if I take the common denominator of 4, what I have is x1 plus x2 quantity square minus x2 minus x1 quantity square. Now when I square a binomial, I get x1 square plus 2x1 x2 plus x2 square. And when I square this binomial, x2 minus x1, I still have the same first and last terms, which is x2 square plus x1 square. But I would have minus 2 x1 x2. So really, they will cancel each other. A lot of terms cancel each other out. The only survivors from here are 2x1 x2 minus, and then this would be negative 2x1 x2. Similarly, here I would copy these two terms, the first two terms, y square minus y times y1 plus y2 plus the same idea applies. I would have 2y1 y2 from the first term minus negative 2y1 y2 is equal to 0. That's the right side. So let's go ahead and simplify. This is going to be 4x1 x2 divided by 4. So that's just x1 x2. So what I have is x square minus x times x1 plus x2 plus x1 x2. And then here I have y square minus y times y1 plus y2 plus y1 y2 is equal to 0. Now notice that these three terms, x square minus x times x1 plus x2 plus x1 x2, this can be factored. This is a quadratic expression in x, which is saying that the coefficient of x is negative sum of x1 and x2, and the constant term is the product of x1 and x2. Similarly, this can be factored. Now, how can I factor this? Well, it looks like x1 and x2 are the roots of that quadratic if this was set equal to 0. So it's going to be x minus x1 times x minus x2. x1 and x2 are the roots of that quadratic, and this is the sum and that's the product. And similarly, I would have y minus y1 because it's the same expression except x's are replaced with y's. So you have got that y minus y1 times y minus y2 is equal to 0. And that's the end of the proof.